How's it going, guys? Here we go for our second piece for Chapter 1, the basic fundamentals for chemistry. Chemistry also involves certain things such as the hypothesis for the Big Bang Theory. How did we come about in this world? How is it possible that we have life on this planet? Some of these really large overarching questions that people have always wondered about but never could find an explanation for. So for example, the Big Bang Theory is basically a theory about explaining how the universe was formed with a gigantic explosion, or we're called the Big Bang. Now, they do have to provide support in the theory. It is not just a random opinion or hypothesis without any sort of empirical evidence. What needs to have is, in this example, they provide support about an expanding universe with data confirming that. They provide also information about background radiation. That may include light waves, microwaves, UV ray, ultraviolet, whatnot, and then primordial helium as support about this theory. So again, when these theories are put in place, it is very grounded on a lot of evidence that has been done experimentally and proven for that matter. So moving along with chemistry, chemistry really has multiple theories in play. We're going to be talking a lot of those, and you've already covered those before. But going back to this idea of studying matter and changes, the change of matter is very important, because if you understand how matter changes, you begin to understand and predict how exactly this is going to work and play out in different types of cases, such as pharmaceuticals, such as agriculture. So we go on in here. Matter, if we, by definition, is anything that occupies space and has mass. Now there's a whole section on dark matter, which we'll cover here. But anything that we'll just, for namesake here, for just keeping it simple, matter is anything that you can touch. A substance is a form of matter that has a definite composition and distinct properties. Now this is actually something that we need to clarify here, because sometimes if you want to break down matter into multiple sections, you get to define matter in different languages. Well, in English language, I suppose, but in different domains. So here's an example of a substance that has different types of characteristics. So for example, if I take a look at liquid nitrogen, or symbol N, you can see that it has a very distinct properties, such as that it can actually have gas, it becoming a gas form under room temperature, or gold ingots, which are pretty much solid bars of gold that are elemental as well, but they're in a very, very inert type of reaction. And we also have silicon crystals, which basically are in a crystal format. So these are all examples of matter, but they're all different substances. Now, a mixture is when you begin to mix these two things together and they begin to retain their distinct identity, but sometimes when you add them together, something happens to that, and there's some sort of change that goes with it. The first one's called a homogeneous mixture. It's a mixture that composed of things that is the same throughout. So think of things when you mix them together, you get a homogeneous mixture, such as milk as an example. Milk, if you mix a couple of different chemicals in there, you have a little bit of fat, you have a little bit of protein in there. It looks consistently white. The example here is if you take a look at milk, soft drinks like soda, or even soda here that you have, it all looks the same, although they're undergoing their own types of changes. A heterogeneous mixture is something that is not uniform. So for example, if you take a look at cement, you add iron fillings and sand, it does not look the same, although technically speaking it has a very similar characteristic. If you pick up the sand filings, you can actually end up getting pieces of a certain piece of sand or cement. So again, we're going to use these vocabulary to begin to start thinking about definitions and also the application of different substances as they begin to get mixed in together. Now, how do you separate stuff out? So when you mix a bunch of things in together, different substances, you should be able to remove them out. And there's different techniques that we'll be learning in the lab to be able to separate these things out when you mix them. You can always use what I call a physical means. So an example is called a distillation device. Now in this case, we're evaporating water out, technically speaking, and clearing it all out from its existing minerals and salts that it has inside using a distillation device. And the way it works is that it's a physical means of separation, which means you're boiling this and you're changing the phase of matter, and it's rising to the top and then it's condensing back into a liquid form, but it removes a lot of what they call the distillates, or any of the old particles and minerals that you don't want. This is a great way of separating things out. Boiling is a great example of removing any impurities from water. That's why they use it for water purification purposes. If you take a look at a magnet is another example of something that you could use to separate out the iron fillings. Now, this is called physical means, and some substances can be removed easily using magnets and evaporation and whatnot. Others cannot. But there are ways in which you can chemically remove it as well. Now, an element is something that cannot be separated. So if you take a look at the periodic table, all those elements cannot be separated. They are bounded by atoms and also protons, neutrons, and whatnot. And they cannot be separated by chemical means. So definitely not physical and definitely not chemical. There are 114 plus elements that have been identified. And if you take a look at how many of those, 82 of those are occurring on Earth, which include gold, aluminum, lead, oxygen, carbon, just to name a few. So the remaining of those could be either found on other places on the planet or are man-made. Now, here's an example of elements that you may have come across with on a day-to-day basis, like example aluminum, which we use them in soda cans and different types of metals, and sulfur, which has a very strong smell, is naturally occurring on Earth. 32 of those elements have been created by scientists, so it's very interesting to see that man has found a way, mankind, I would correct myself, has found a way to actually create their own element. And that has led to many different possibilities for what happens when you build, when you create new elements. I mean, this is an amazing feat because you're now not limited by what you have, but what you can create. And these are some of the examples they have created in the lab. Now, here are some of the common ones, and I do expect you guys to at least memorize these on some level. I'm not going to go through these, but these are something that we consistently use as part of equations, as part of learning about chemical reactions. Now, a compound is a little different. A compound is something where you combine different elements together in fixed proportions. Now, it's a little different from a mixture. And the example is compounds can be separated into by chemical means. So you cannot really separate these out by physical means. So for example, if I have lithium fluoride, I wanted to separate the lithium and the fluoride, I cannot do that by boiling it, and I can't do that using magnets because these have already been bounded by different atoms together at the subatomic level. Quartz is another example, and also carbon dioxide, which is dry ice, which is carbon dioxide, solid carbon dioxide, cannot be separated out. So if I want to separate the elements like carbon and oxygen, I would have to use a chemical reaction of some sort to remove those two out, which is possible for me to go back to its elemental form. So in a nutshell, to summarize, here's the classifications of matter. Now we're going to be exploring different types of matter and also different types of substances and how they react. So for example, if you take a look at matter as the general overview, underneath it you have things like a mixture and a substance, and then from a substance you can separate them out into a compound and then to an element. On the mixture side you have different heterogeneous mixture and homogeneous mixtures. Alright, thank you very much.